Good evening and welcome everybody. This webinar is about server architectures. I'm Jebin. I'm a software architect, author, full stack engineer, front-end specialist, and a tech polyglot. These days, I'm mostly working on bot platforms, contributing both to the application layer as well as the intelligence layer. Along with that, I'm also contributing to Qarrots.com, which is a curated knowledge building platform. I'm also part of itbytes.in, which is a training initiative to bring up individual contributors for the industry. This webinar is all about server architectures. Before diving deep into server architectures, I just want to share a peculiar experience I had developing a particular server. In the past, I got opportunity to develop messenger applications. I was responsible for developing a web messenger, and also I was given the opportunity to develop messaging servers. So this messaging server is very peculiar because it is a critical component of the whole ecosystem. If this messaging server doesn't work as expected, then none of the messages in this entire system will be relayed through. So if you see, this particular server is responsible for the whole ecosystem to run without any problem. So the first problem that needs to be addressed is scalability, wherein it should accommodate more than 1,000 requests per second. Second thing is there should be absolutely no downtime. So why am I talking about this specific message delivery server? Because I enjoyed developing servers as much as I enjoyed developing front-end applications. And in the course of time, I got to develop a lot of other server applications as well. And in the course, I learned different architectures which is suitable for different types of applications. And in this webinar, I'm going to share all of those information with all of you. Before diving deep into the server architecture, I just want to cover a bit of basics. So when I say servers, there is an ambiguity. For all the newbies, there's a confusion what these servers exactly mean. In the hardware world, servers mean server applications. Servers mean actually server machines. But in the software, servers mean server applications. So these server applications are nothing but those applications that respond to the request those clients are requesting for. So these server applications usually serve different kinds of responses, including files, or different types of responses, including JSON content or text messages or some dynamic content. So based on this differentiation, there are two types of servers, and the other one is application servers. The web server's responsibility is to respond with assets. It could be HTML, it could be JavaScript files, it could be images, or it could be CSS files. But they all do this responses over HTTP. When it comes to application server, things get really interesting. The application servers run the actual logic that the developer wants to run. Example, if someone tries example.com/user, the user will be able to see his profile if he is logged in, or he'll be able to see the login page. So now, this particular application logic can be run through one of the languages preferred, but with the help of application servers. There is a huge difference between the web server and the application server, because web servers' responsibilities and their capabilities are very limited. But when it comes to application servers actually can communicate over different protocols, including HTTP or sometimes they even do with RPCs. So that is the basics about servers, server applications, and the different types of servers. Now, these leads to a different world, which is the server architectures. So the application servers are complicated, where people build all kinds of applications. It could be small, it could be big, it could be complex, it could be distributed, and the scope of the application actually determines the architecture of the servers. So with this scope, if I have to broadly classify the architecture of the servers, then I can put all of these applications into 4 architectures. One is monoliths, the other is tier-based architectures, and the next one is microservices, and then now we have serverless architectures. We'll see each one of these deeply in the next few minutes. So the first one is monoliths. Monoliths are simple applications. They are just one big block of application. So a typical example would be a WordPress blog. If you see, if anybody who had developed a WordPress application or a WordPress blog would probably know that all the application logic, the database access, as well as the presentation layer, everything is all bound into one single block of application. Now, the monoliths are easy to manage. That is one of the biggest advantage of monoliths. And if you see, mostly monoliths will have only one language involved in developing this application. But what is the disadvantage of the monoliths? The first biggest problem with monolith is single point of failure. Let's say the application logic has some failure, then there is a high chance that the whole system could become non-functional. So the database layer, let's say for some reason, goes off, then the whole system again will be stalled or will not be usable at all. So this is the biggest problem with monoliths, because of which we started evolving around and we got into the next architecture, which is the tier-based architectures. Now, the tier-based architectures are popularly called entire architectures, where based on the necessity, we can put different responsibilities into different tiers and we can have multi-tier architecture. But in the web world, the most popular tier-based architecture is 3-tier architecture, wherein you create different tiers based on the system level responsibilities. One of the tier could handle the complete data access, which is your storage and storage related work. And another tier could accommodate the business logic, which is the actual application logic. And there could be another tier which handles the whole presentation logic. And the important characteristic of tier-based application is that each and every tier should be independent of each other. That is, each tier could be run in different physical machines. They could be upgraded individually, and each one communicate with each other with the help of APIs or RPCs. Or in fact, you can do the communication with the help of inter-process communications also. The biggest advantage here is that each tier can be developed independently with the different languages or different tech stack. And you can have a big team contributing to each one of these tiers independently. And what is the advantage of tier-based architectures over monoliths? Here again, the important advantage here is the data access layer, the business logic layer, and presentation layer are all running in different machines, because of which you can accommodate different kinds of logic or different kinds of tiers individually within these big tiers. So that is one of the biggest advantage of tier-based architectures over the monoliths. The next most popular server architecture is microservices. So if you ask me what brought microservices into so much light is the need for componentization. So previously, we started developing applications thinking that the whole application will be scaled as one big block. Even in tire-based architectures, we had an assumption that the whole unit will be actually working together to bring up results. But as we evolved, the server architecture started becoming complicated that we needed applications to cater the needs of various applications which had variety of needs. That is where we wanted componentization very badly, and that gave rise to microservices. The principles of microservices are just these two things. One is the application or the service that we are creating should do one thing at a time, and it should do it very well. And the second thing is we have to divide the responsibilities of the application at feature level, and we should develop services which will do the job for us. If we are able to componentize and break down the features of the application into small services, that is how we get to the microservices. For example, authentication service can be an individual service of the whole application. So similarly, let's say if your application has feeds, in that case, feeds could be rendered from a different service altogether. Similarly, image processing, data services, web APIs, and so on, we can actually have a lot of examples which can go into microservices. Now, how do microservices communicate with each other? Again, each microservice exposes APIs, or they can communicate between each other with the help of RPCs or with the help of inter-process communications. Now, these microservices are mostly independent, and they could be run within the same machine or from different machines. The important thing is each service need to know how to discover other service if they are dependent. Now, before telling the advantages of microservices, I just want to point out all the disadvantages of microservices. The very first thing is unsafe distributed communication. Given that all the services run in different machines or in different processors, the communication between these services needs to be established very well, that there is a possibility this communication could be lost. The second important problem is the maintenance. From the developer's world, the microservices are overhead to manage because each service has its own configuration, its own requirements. So the DevOps team will have overhead of work to manage each of these services. Again, each of these service holds one responsibility. So moving responsibilities from one of the service to the other service will be a cumbersome job. And moreover, if the services have dependencies over other services, then upgrading these services will be a tricky problem. And also, scalability comes into picture, wherein scaling each one of these services individually will be a problem. And the transactions, if say you have to run series of operations as one transaction, there is a possibility of failures in the middle, and there is no guarantee that the whole transaction completes. So these are all some of the disadvantages of microservices. But still, why microservices are very popular, and these days most of the serious applications being developed are all being developed with the help of microservice architecture. Why? The reason is, in the end, the customers want to see your application running all the time, even though if one or other feature is not working. So microservices are capable of running throughout, even if one or the other service is non-functional. If you take monoliths or tire-based applications, If there's a problem in one of the tires, or if there's a problem in one of the application logic, there is a high possibility that the whole system might be not functional. But in case of microservice, if one of the services is not functioning, still rest of the application will work, just that this particular feature might not be available if we engineer it properly. That is the biggest advantage of microservice, and that is the important reason people are moving towards microservices. And other advantages are like each service can be developed independently, and languages, again, it's up to the developers to choose which language goes well for each of the service. So let's say one of this service handles the messaging. Then you can use Phoenix framework from Elixir language. Then you can have your application server completely built on other technology. And then you can have your views, the presentation layer completely built on completely different technology. So that is the power of microservice, because of which these days microservices are preferred in terms of building server applications. And the next one, which is getting popular these days, is the serverless architecture. So when we say serverless, that doesn't mean actually there is no server, because you cannot run an application without servers here. The server applications obviously needs servers. But here, what do they mean by serverless architecture? So they mean that you don't have to manage the servers in which your application, server application, is running. If you take all the other three types of architectures, you have to manage the infrastructure overhead, the platform cost, and other integration details. And also, DevOps have plenty of work to do when it comes to other three architectures. But in the serverless architecture, the providers of such architecture will be able to take care of all the the physical machine related needs in terms of scalability, in terms of the infrastructure, in terms of language dependencies, in terms of storage also, the providers will be able to take care. So all we need to do as developer is to concentrate only on the application logic, which can be built as a function or as a backend as a service model. Now, when we talk about serverless architectures, there are two types usually how people develop applications in serverless architecture. One is backend as a service, and another one is function as service. So in backend as service, what happens is there is no controller component in the whole application. Instead, there is database and there is client. The client application knows how to invoke or get data from the database, which means the database is directly accessible for all the clients. So this is how backend as a service architecture is actually coming up. And the next one is function as a service. So here what we do is we develop the whole application logic as small functions, and just we deploy with one of the providers, like say for example AWS Lambda or Azure Functions, where you put your function and these providers will take care of all the aspects of running this particular function. So they will provide an API gateway, which is nothing but a URL to point to your function. So whenever this URL is called, this function will be executed from the provider end. So in terms of scalability, in terms of availability, all of your maintenance cost and overhead of maintenance, everything is taken care by the provider himself. But the only problem here with the serverless architectures is states, because any serious application that you want to build needs state management. So if you take one of these providers, any providers for that case, you don't get to have your state management within these applications because they are completely stateless. Let's say you deploy a function just to do a product checkout or product cart management. You don't get to store your states in the session because these functions will be executed in different processors based on the number of requests that are flowing in. So what do we need to do to solve the state problem is we have to expose APIs from the storage layer which can be consumed from these functions to do the state management. Or if you want to manage sessions, it is probably good to put Redis kind of cache into which you have all your state management happening. But what is the advantage of serverless architecture? The biggest advantage is that the infrastructure need not be maintained. That is why actually they call this as serverless, and also it is all cost efficient. Instead of owning a server and then managing it and then deploying your application and also taking care of different integrations, here everything is actually taken care by the provider himself. We just have to provide only the application logic. That is the biggest advantage. But the disadvantage is that these serverless architectures are mostly useful for simple applications. We cannot create a full-blown, serious, let's say, a messenger application or a bot platform with the help of serverless architectures. So these are, if you want to build an application which needs to be going to the market as soon as possible and has very limited functionality, then serverless architectures are really good. Now, what are the pros and cons, or how do we compare between these architectures? Or if I have to put it precisely, when do we choose which architectures? So when you have a very simple application where the scope is very limited, in that case, either serverless architecture or monoliths are better choices. But if you think that you need to scale well and your application will grow and that you will have in the future more developers working on your application, it's best to choose either tier-based architectures or microservices. Again, between these two, I would prefer microservices because they help you to plug in and plug out features, and these services will represent your features. In that sense, scalability-wise, and also in terms of scaling applications in terms of features, microservices will help a lot. So tier-based application, one of the important problem is, let's say if there is a problem in application tier, then the whole system might become non-functional. And these days, componentization is taking over the whole web industry. In fact, if you see the front-end applications, the frameworks like Vue.js or Angular or React is taking over because they help to build applications with the help of components. You build your whole application with the help of pieces of components, and then finally you tie them together with your routing mechanism or some sort of application logic. That way, all the components are self-sufficient mostly, and they will communicate with each other with the help of events or through APIs to do their functionalities. So in that sense, more than tier-based architectures, microservices are really good, just that you need to actually take care of the overhead and cost of managing the services. Because once your services go over a particular number, it's really hard to manage them. So you need a dedicated DevOps team to take care of all the services. Again, scaling comes into picture because you need to scale individual services based on the number of requests coming to these services. It is an advantage as well as a disadvantage, because scaling individual service is something which needs to be taken into account very seriously. But at the same time, based on the requests that are coming to a particular service, you can move the services to high availability and less availability modes. That is the biggest advantage. That is one more advantage that I see of microservices. Now, when we talk about all these architectures and servers, one of the important things that we also need to talk about is availability and scaling. So availability is nothing but how to get your application highly available, which means there should be absolutely no downtime. And your scaling means that how could you accommodate more and more requests that are flowing into your web application. So these two aspects are I would say, the most critical performance metric for any serious web server or server applications. So both this availability and scaling can be combined together sort of in scaling itself. So in that sense, scaling can be broadly classified into vertical scaling and horizontal scaling. So let's say you have a server application running and per day you have 100 requests per hour. But then all of a sudden you did some good marketing and then you started seeing more traffic coming in to your application server. So what happens? You need to provide more resources for the server, like in terms of CPU and in terms of RAM, so that all these requests can be accommodated and processed rather than queued for a long time. So scaling vertically means that you add more and more resources to your physical machine. That will hold up to only certain extent. One machine can accommodate only certain amount of requests. It cannot accommodate more than certain amount of requests. That is where the next level of scaling comes in, which is horizontal scaling. So here, horizontal scaling means you're not stuck anymore with just one machine. Instead, you can put your application into multiple machines. That is, you take a copy of your application and you run the copy into multiple servers. And all the servers are connected to one common load balancer, which will be the point of contact for all the clients. So whenever a request from the client comes to this load balancer, the load balancer employs one of these algorithms based on choice. Maybe it could be round robin, or it could be first come first served, something of one of these algorithms. And the request will be routed to other servers, your application servers from the load balancer. So this application servers and then will do the application logic, and they'll create the dynamic content, and the same request will be responded through the load balancer. But what is very critical about horizontal scaling is that the state that you can find within your application should be externalized. Because when you have multiple servers running the same code, it should not do the same process from two different machines, or it should not do a same action, let's say updating password or creating user. It should not be creating the same user twice in the system. So for that reason, it's always good to externalize your state if you think that you have to do horizontal scaling. And the biggest advantage about horizontal scaling is that even if one of your machine goes down, maybe because of data corruption or because of network issues, even if one of your machine goes down, there would be another machine which is connected to the load balancer, which will be able to accommodate the rest of the requests. So that way, there would be absolutely no downtime. And also, this particular scaling method will allow you to scale infinitely. So based on the number of requests flowing in, you would be able to scale the whole ecosystem by adding more and more resources as per the number of requests flowing in. And so that is all about the server architecture. If you like this webinar, please hit the like button. And we will be actually delivering a lot more webinars in the future. If you're interested, please subscribe to this channel. It's time for question and answers. So if you have any questions, please post them. I'll be able to answer from here. In the meantime, I'll be answering some of the questions I got earlier before starting this webinar. The first question is why microservices were not introduced earlier. Okay, so it's an interesting question where even though we know that componentization actually does a good job, why didn't we actually pick it up earlier? So it's all part of the evolution process, wherein we did a trial and error. In the beginning, we started doing some monoliths, and then we evolved, where we started doing tier-based architectures because we wanted to scale the responsibilities independently. And now we are in the era where we have enough resources, both in terms of manpower as well as in terms of servers and softwares, because of which microservices are now at its prime time. So the next question is how to design microservice applications. So designing part, I would say the thumb rule would be, when you have your application requirement, try to break it down in terms of features. And now count how many features you have, and that many services are good to have. You can combine some of the services, or you can still divide some of these services to create multiple services. But again, the important thing would be how you develop your service should be based on the number of features that you're developing. Maybe your authentication could be one service, your access control logic can be on another service, and then maybe user management can be on one different service. So similarly, you can have multiple services based on the features that you want to develop for the whole application. So that way, you will design a robust microservice application. So what are the tools and programming languages needed for microservices? So in terms of tools and programming languages, I would say microservices are so open that you can choose any kind of language that you like, because each service will be running independently. And if you think one of the service can be run better by a particular language or a particular technology, you're free to choose that. Here, there's no restriction, because each one of this process will be running individually. All that matters is how do they communicate between them. Here, the latency should be as less as possible. So it is always important that these processes should be running within a network where they are easily discoverable and the latency is almost negligible. That is all the important criteria. Other than that, there is not much restriction for developing microservices. So what are microservices? Again, I have addressed this question earlier in the webinar. So microservices, again, as I said, you develop the whole application as small services, and then you tie them all together to bring up your application. So when a request comes to your server, the server will redirect the application to one of the modules based on the configuration, and these module or the service will do the application logic or whatever it has to do. It will do that, and then it will return the response. So what architecture to use for my distributed server? Okay, so this is a ambiguous question where if you say distributed server, so distributed server here means many things, because typically if you take a server or client server architecture, it's a simple version of distributed server. Now, when you start scaling them, that is the same thing I was explaining in the horizontal scaling, where you put a lot of machines, the same code or different code, all running together under a load balancer, where you start actually directing all your requests to the load balancer, and then you have a series of nodes where this request will be directed to one of the node which has relatively less load. So in terms of such kind of architecture, so what you need to do is always try to put your application in a way that the state is externalized. You don't put any of the state in the local memory. So let's say, for example, you have some session management. Your session management cannot happen just in one machine. So in that case, your session management should happen somewhere externally so that it can be accessed from all the machines. Let's say one person is logging in via one node. Then this node alone has that session, and if the next request, subsequent request, goes to another machines, then there is a problem. The problem is that this session is not shared among all the servers or all the other nodes, because of which the user might get again, the system might ask him to actually log in. So this kind of problems will arise because of state management. So if you are able to externalize all the states from your application, that would be more than enough to create a truly distributed servers. So how to understand system design? So that is a very broad question. So how do you understand a system design domain? So the system design usually comes by practice, one thing. So second thing is you need to observe the scope of your applications. The first thing is you have to choose the right tools and technologies to build your system. So second thing is you have to understand the whole feature set, and also you have to keep in mind that softwares always evolve. So it means today if you're developing with one stack and one technology, tomorrow there might be a necessity that you have to move on to newest technology or tech stack available. So in that sense, when you think about system design, it's always good to actually keep it as open as possible. Okay, one thing. Second thing is it should be robust, that tomorrow if we want to accommodate a change, we should be able to do it without disturbing other parts of the application. Hope that answers the question. And any other questions from the participants? Any other questions? I think there are no other questions, which is okay. So feel free to ask your questions in the comments. As in when I get some time, I'll come back and answer all your questions. The next thing is an announcement from my side. So as I said earlier, I'm part of itbytes.in, which is a training initiative to bring up individual contributors for the industry. So being so much associated with startups these days, I feel like individual contributors for this particular role, there are very less people. So we wanted to train some of the young individuals, and we want to prepare them to be individual contributors. So if you know someone who deserves to be trained well and to be put into some niche startups in the current market, please let us know. Your feedbacks are welcome. So based on your feedbacks, we'll be able to deliver more quality content in the future. So there is a form available in the description. Please fill out this form with your feedbacks. And if you want us to deliver webinars in the future with some different topic, even those feedbacks are also welcome. We'll take those into consideration as well. Please provide your feedbacks. And once again, thank you everybody for joining, and see you in the next webinars. Thank you.